So let's examine the Python code for doing survey data analysis using a bit of data science methods. And we start by reading in the data. Well, we actually start by importing a few libraries that are essential for making it easy to read and work with the data. Here we load the data in from a CSV file. The CSV file looks like this. So there's various different kind of variables, and then each row is one response on this. And as you can see, there's a lot of responses on the word value survey. And this here just sort of prints us how many different kind of values there are. So once we read this, you see that 45,000 people have answered 2 to this particular survey, and then 2,000 people have answered 4 to this survey item. So in Python, we use this specific library called scikit-learn to make some things happen, but the process itself is quite similar to all of the code and all of machine learning. So again, we import some important libraries that we need, and here we formulate the data into a format of y and x. So y refers to the data that we are trying to predict from or try to predict the values of. So here we want to predict a variable temp, which is something like how happy you are. So the same variable that we were looking at there. And then we call it just y for clarity. And this here, we take the data set and then we remove this 10, a v10 from that data set, so that we don't end up predicting using the same value that's the value that we were predicting. So y contains only v10 and x contains everything else than v10 at this point of time. Well, actually, we want to simplify this problem a bit. So we are going to work through or focus only on variables v4, v5, v6, v7, v8, and v9. So here we choose only those variables from all of the variables, and then we do this test and then train splits. So the important variables here, you need to have both x and y, obviously here. So we are splitting these into x train, x test, y train, y test. And we make the split so that the test data is about 30% of the whole data set. And we can again sort of examine that of course the y, the train data set is much larger. That is obvious. The test data set is smaller, only 30% of that. We have the same distribution of data between these different conditions or different things. So y train is just a small portion of everything, and the same actually is x train and x test are similarly done. So here we define, or let's move now, once we've been able to produce this split between testing and training, which is essential to supervised machine learning. Let's move into the model fitting and model evaluation. So here, this line or this line of code says that we build a model using decision tree classifier, and then we use the training data to train or fit this model. So running this makes so that the model is now something that tries to make predictions, that if it sees data similar to the data x train, it will produce predictions on values of y. This is actually what we do here. So So we want to do a prediction. We give it test dataset, not the training dataset. We use that for making the training happen. The test dataset of X, and then we get predicted values of Y. And now comes the sort of important part in all of machine learning, which is that we need to evaluate the model performance. So what it means is that we have here the predicted values, and then we have the actual values from the data, the test part of that data. So we can produce this confusion matrix, and then we can also produce more accurate values of what's going on in this classification. So overall, the accuracy of the model is 51, which is really bad, really bad. Here, how you should read this table is that here are the rows are the predicted values, and columns are actual values from that data. So here is 1, 2, 3, 4, 5, 6. I should have printed the labels there as well. Here is, I'm trying to find a row that would nicely sum into one of these. So here is -5. We had only one value of -5. So it was predicted to belong into that class there. Similarly, here would be -2. So all of these row values, that sums into 59. And you can see that the value -2 is predicted into quite many different values. So that's the reason why the model is so bad, is that you can see that those are quite scattered around. Here are some exercises that you can use to work with this and understand a bit more on what's going on here, and try to improve the model. But we also want to sort of show how to do unsupervised machine learning using Python. So whereas in supervised machine learning, what we really wanted to do was to predict this Y, the V10 of data. In supervised machine learning, we just want to make things happen. We want to create groups from here, and for simplicity, I've taken a small subsample of the data, so that it's easier for us to work with. We built the model. We say that we want 5 clusters from that data. And once we run it, it produces us the 5 cluster. Here you can see that we use this called fit and predict and just give it the data, because we don't really have anything. So in supervised machine learning, we were doing this prediction fitting separately, doing careful work to sort of examine the classification results and those meanings. Here we just do fit and predict because we don't really have a baseline to which compare, because we don't know. We ask the computer to produce those. Here we assign the cluster values to each of the data point, and then we just compute the means of variables. So here are the clusters, and here you can see some of the means between those. So for example, you can see that on V6 here, the different clusters do fairly similarly. So all of the values are around 2, more or less. On V3, we can see that there's slightly more variance. So this is for cluster 1 or cluster 0 from this. The value is 244. For cluster 1, it's 300, 249, 273, 234. So we can understand what's going on with the clusters that we've just produced.